Alright, what's up everybody? This is Wallace from A3Academy, and today we're going to be talking about continuity, some pretty important stuff when it comes to calculus, so let's get started. So suppose I had this function right here, we'll call it f of x, and we can say that f of x has this property that it is continuous at the point x equals c if one of these conditions are met. So if it is an interior point in the function, that means it's not an endpoint, then the function will be continuous at the point x equals c if the limit of f of x as x approaches c is equal to f of c. And if it is an endpoint, like one of the end part of the graph, if the limit of f of x is equal to f of c as x approaches c from either side, positive or negative, then it is still continuous at that point. So let me explain it a little more. So if we took this graph of this function and we kind of drew a horizontal and vertical line on one of the points, you can see c and f of c like that. So the first thing you'll notice is that the left hand and right hand limits to the point x equals c are the same, and the value for this limit is equal to f of c. So since we know that the limit exists on both sides and that limit is equal to f of c, we can determine that it is continuous at that point. So f of x is continuous at the point x equals c. Now, if you take a look at these endpoints here, the limit doesn't exist on both sides of the point, so only one side of the function exists. So the one-sided limit can be taken from either the left or the right, depending on which endpoint it is, and as long as that limit is equal to the value of the function at that point, it is continuous. So we can say that a function is continuous at a point x equals c again if it is an interior point, if the limit of f of x as x approaches c is equal to f of c, and if it is an endpoint, if the limit of f of x equals f of c as x approaches c from the positive side or from the negative side, depending on what endpoint of the function it is, the left hand endpoint or the right hand endpoint. If we had these two functions, f of x and g of x, and we knew that both of them were continuous at x equals c, and we added them, the result would also be continuous at x equals c. And that's also true if you subtracted or multiplied or divided, or you took the composite, or you even multiplied one by a constant. It'll be continuous at x equals c regardless. Alright, so there's a different kind of continuity called continuity over an interval, and when a function is continuous over an interval, that means that the function is continuous on every point in the interval. So, for example, if we took our function from before and we took the interval between the two dotted lines, since you know the function is continuous from every single point in that interval, we know that that function is continuous over that interval. So that's continuity over an interval. And then we have a continuous function. A continuous function is just a function that is continuous on all points in its domain. So that means that if we had a function like y equals 1 over x and we graphed it, every single point on its domain would just be every single number except for 0. You take a look, obviously the right hand and left hand limits for x equals 0 are not the same, which means that the limit doesn't exist, which means that there technically is no continuity at that point. But since x equals 0 is not in the domain of y equals 1 over x, it technically doesn't matter. It's still going to be a continuous function because it is continuous at all other points except for x equals 0. So sometimes you will get a function that is not continuous at a couple points, and so these points are called discontinuities. So the discontinuity in this case is the point here, and it is a jump discontinuity. So there are four major types of discontinuities. The first one is a removable discontinuity, and that's basically where the limit from both sides exists. However, there is no value for the function at that point. So this is pretty much when we have a smooth continuous function except for one hole that is in the middle of the function. So that's a removable discontinuity. Then we have jump discontinuities, which are when the limit on either side of the point does not exist, even though there might be a value for the function at that point. So that's a jump discontinuity. It's called a jump discontinuity because of that jump that you can see there. Uh, then the next one is an infinite discontinuity. As you can see, the limit from both sides reaches either infinity or negative infinity, and so that's what we will call an infinite discontinuity. And then we have an oscillating discontinuity, and this is actually not used a whole lot in calculus, but an oscillating discontinuity is when the a function oscillates around a certain value so fast that it is impossible to tell what the value of the function is at a certain point. So, for example, y equals sine 1 over x is a good example of a function with an oscillating discontinuity at x equals 0 because there's no definite value for the function at that point. It just doesn't exist. So that's all you really need to know about the types of discontinuities and how to define continuity in general. So that's all for today. I'm Wallace from A3 Academy, and as always, the more you know, the better you are.